Now we're going to talk about some forms of logical arguments, valid conclusions that we can make based on given information. Okay, to do this, the easiest way is going to be to use the symbolic form. So what I'm going to do is I'm going to use some examples. Let's say I'm given these two statements. Okay, what can I conclude, if anything? Is there any valid conclusion I can make from the information given? Okay, let's look at the first example. So unlike when we were learning how to use the symbols, now we're going to have to go ahead and assign the symbols. So remember, if it's snowing, then it's cold. The if part we're going to call our hypothesis, or our P, and the then part we're going to call our conclusion, or our Q. So what I'm going to do is I'm going to use colors as well as letters. I'm going to say it's snowing is going to be my P, and it's cold is going to be my Q. Okay. The second sentence was it's snowing. So I look up at what I've assigned P and Q, and I'm going to decide, is it P, is it Q, is it not P, is it not Q, or do I need an entirely new letter, maybe an R? Well, this is identical to it's snowing. So the first part of my sentence, that was my P. So now what I'm going to do is I'm going to write it in symbolic form off to the side here. My first sentence was if P then Q, and my second sentence was P. Now, when I do this, what I'm doing is I'm actually not thinking about what these sentences mean. Because when you're doing validity of an argument, okay, whether or not there is a logical conclusion, you are not thinking about the meaning of this. We're actually assuming that whatever we're given is true. That's an assumption that we're going to make right now. We're just basing it on logic. Okay, well what we have here is actually called the Law of Detachment, and there is a valid conclusion. So if we were given these two statements, we could make a conclusion. Remember, the three dots mean therefore, or in conclusion, Q. And notice it's called the Law of Detachment because what we've done is actually just broken up our P and Q. Okay, they're telling us if we have a conditional statement and then we know the hypothesis is true, the conclusion must follow. So given these two statements, what I can conclude, so let's go ahead and make the conclusion, is that therefore, we're going to do it in words, therefore it's cold. Okay? You might look at me kind of funny and say, but wait a minute, they already said it's cold. Well, actually they didn't. They gave us a conditional statement that said if it's snowing it was cold. They didn't tell us it's cold. We made that conclusion because we were given these two statements. It's called the Law of Detachment. Okay, the next one I'm going to show you is actually an invalid. Okay, and I'll make sure I make that very clear after I go over it. It's called the converse error, okay? It's an error. It's not valid. But I want to show you this one because it's such a common mistake, all right? Most people fall for this, me included. There are many, many invalid arguments, but I'm only going to talk about this one just because it's so common. So let's use our colors again. If it's snowing, then it's cold. So if I make that original statement, it's snowing P, or blue, and I make the conclusion, or the pink part, it's cold. Okay. So my first sentence that was given to me here was, if P, then Q. Now the second sentence that was given, it's not P, it's actually Q. So, Q. Alright. When I am given these two statements, there is absolutely nothing that I can conclude. There's no valid conclusion. And like I said, a lot of people want to say P. They want to say, okay, well, therefore it's snowing. Well, I'm not saying that it's not snowing. Alright? This is something, we're not talking about true or false right now. We're talking about, if we're assuming this is true, what can we conclude from it? Well, just because it's cold, we talked about that. The converse is not true. So just because we know the first part here of the converse doesn't mean that it's going to be snowing. It might be, but that's not what we're talking about. We cannot 100% say that therefore it's snowing. There's no valid conclusion to this. So again, I want to, I wish I had a big red marker right now. I'm going to put a big X through this because this is invalid. Do not fall for this trap. Okay, would not have a valid conclusion. Okay, so I'm going to show you two more, and I'm going to show them to you at the same time because they actually would have the same argument, just different conclusions. Okay, so if you notice, I've done the exact same argument on these two problems, these two examples. So Law of Syllogism and Law of Contrapositive are given the same information. Their conclusion based on the same information. So if I'm told that if it's snowing, then it's cold, so that same conditional statement that I'm using. But this time, notice, my second sentence is another conditional if-then statement. So it's cold was my cue, and now I've got wearing a coat, which is a total new piece of information. We're going to call that R. So if we do our first sentence, we always want to make our first sentence if P then Q. So we were given if P then Q, and now our second sentence, the hypothesis is the first one's conclusion. Then, and I had a whole new statement here, let's call it R. Okay? So if P then Q, if Q then R. Alright? Now, Law of Contrapositive has the exact same given information, so I just want to go ahead and point that out. If it's snowing, then it's cold, so that's my P and Q. If it's snowing, then it's cold. And if it's cold, which was my Q, then I wear a coat, which is total new information. We're going to call that R. Okay. So again, notice this is exactly the same as this. So if I'm given two conditional statements where the first conclusion is the second one's hypothesis, okay? So notice that these two are the same. Okay? And the same thing down here. These two are matching. The first conclusion is the second one's hypothesis. Well, what this actually is the law of transitivity. Okay? So this is the application of the transitive property. Okay, applied to logic. The transitive property, if you did not learn that in algebra, if you do not remember it, it says if A is equal to B and B is equal to C, then I can make A and C equal. Okay? That's the same thing here. I'm saying if the first goes to the second and that second goes to the third, my conclusion, Law of Syllogism, would be therefore, if the first thing happens, then this last thing will happen. Okay? That is a valid conclusion that I can make given these two statements. So what would that look like in words? Well, P was it's snowing, and R was I wear a coat. So, therefore, if it's snowing, then I'll wear a coat. Okay? Alright, and then my law of contrapositive is the same given statement, but there's another conclusion that can be made here. Alright, remember the contrapositive, that was the longest word, the most work. If you think back to when we defined the contrapositive, we said that the contrapositive of a statement was always logically equivalent. It had the same truth value. Remember the contrapositive, we're going to go backwards and negate. So the contrapositive of this would also have to be true. It's logically equivalent. So in other words, we're going to start here and go back to P, but we're going to negate. So our conclusion would be, therefore, if not R, then not P. And what would that look like in words? Therefore, if I do not wear a coat, if not R, then it is not snowing. Okay? So again, I want to be very clear that we're not talking about whether something is true or false. What we're talking about is whether we can make a valid conclusion based on given information. Okay? When I have the law of detachment, remember, it's not a conditional conclusion. It's just Q. There's no if then in here. Okay? There's no arrows here. So law of detachment says if I'm giving a conditional statement and I'm told the hypothesis is true, I can then therefore conclude that the conclusion will follow, the Q part. Okay? So therefore it's cold. The converse does not work. And then I have two laws dealing with two conditional statements. These work if and only if the first conclusion is the second hypothesis. Okay? When that happens, I can make two conclusions. The first one is that the first will lead to the last, so if P then R. But the contrapositive of that is also true. So if not R, then not P is the second conclusion that I could make given those statements.